Welcome back to the course on symmetry, stereochemistry and applications. So, we were trying to understand the different rules of IUPAC nomenclature for various organic compounds. So, in the previous two lectures, we have learnt about how to write the names of organic molecules for simple hydrocarbons, substituted hydrocarbons, and then we also learnt about the naming of alkenes. So, in that direction, we would continue to understand the names of alkynes. As you know, the alkynes are the compounds which contain a CC triple bond, and these are as usual reactive in nature due to weak pi bonds. The first member of this series is the ethine or acetylene, which is identified as C2H2, but you can understand that there may be a large number of different compounds which can have CC triple bond. And you may have noticed that cycloalkanes and alkadines have the same general formula as alkynes. So, we will continue understanding the names of alkynes and alkadines in these upcoming slides. So, we will first see what happens when you have different types of alkenes and alkynes connected together. So, the first point that again and again we should remember that we need to find out the longest carbon chain, and that longest carbon chain need not be the one which has the multiple bond. So, for example, in this particular case, you have a molecule written here in the first in the upper portion, where you can number the atoms starting at the point where the double bond starts, and then number it like 1, 2, 3, 4 and 5 as is shown in the upper structure, and you can try to write their name like that, 2-ethyl pent 1-ene. But you see, in this particular case, the longest chain is neglected. The longest chain is formed by numbering it from this particular end, where you have 1, 2, 3, 4, 5 and 6. So, it becomes hexane, and the substitution that is here is a methylene substitution. So, when you try to write the name of this compound, we do not take the longest chain containing the CC double bond, rather we take a longest chain which is not containing the double bond, and the double bond is outside the chain. So, we write this as 3-methylene hexane, 3-methylene hexane. Now, you see here in these examples, we have a situation where we can identify a double bond and a triple bond in the molecule, and depending on from which side we try to number, those double bonds and triple bond gets different numbering. So, when you try to number it from the right hand side, giving priority to the triple bond, the number gets 1, 2, 3, 4 and 5. So, number for the triple bond and double bond is 1 and 3, whereas if you try to number it from the other end, then the position of double and triple bonds get numbering 2 and 4. And here we need to remember that the sum of these two numbers should be the lowest for a correct numbering. So, in case of the left one, we have 1 and 3, which is the sum is 4, and in the right hand side it is 2 and 4, the sum is 6. So, this sum gets priority over the other one. As a result, we write the name of this particular compound as pent 3-ene 1-ine. You must notice two things. Number one, when I am writing "in" designating the double bond, instead of ENE, we are writing only EN. We have dropped that particular E, and we also have identified the double bond as E, which is entgegen, that is in opposition to, because about this double bond, these two groups are on the other side, opposite sides of each other, making it so called trans, and in this particular case we write it as E. Now, we have a different situation here. What we have is a molecule where at two terminus we have a double bond and a triple bond. So, there are two different ways of numbering it. We can make it as 1, 2, 3, 4 and 5 from the right hand side, or 1, 2, 3, 4 and 5 from the left hand side. So, when we write it in the way that the 1 identifies the triple bond and 4 identifies the double bond, the name should have been pent 4 in 1 ine. Whereas, if we write it in a different way with double bond getting priority 2 and 1 and triple bond getting the position 4, we can write this name with giving the double bond priority as 1 and triple bond priority as 4, and write the name as pent 1 in 4 ine, which is the correct nomenclature that we need to know. So, here the rule is, if the same set of numbers is obtained by counting the in either direction, the number assigned in the alphabetical order. So, in comes before ine. So, in gets number 1 and ine gets number 4, and that is why we write pent 1 in 4 ine as the name of this molecule. Now, we have a slightly difficult molecule. You can see here in this particular molecule we have 3 double bonds and 1 triple bond. There are many different ways one can start numbering it, and from the previous slide we have understood that if we have in and ine, we should give priority of in above ine. So, we should start numbering from the end where the double bond is numbered 1 and triple bond is numbered the lowest. Now, we can come from this end and write the numbers 1, 2, 3, 4, 5, 6. Now, we need to see whether we should go towards that or towards this. So, here you have two possibilities, going up or coming down towards the triple bond. So, again now we again refer to a new rule where we learn that diene has a higher priority over enine. So, if we write the numbering from 1 to 8 on the inside, then it is named as diene, and that ine is a substitution. If we write it from this 1 to that 8, then it becomes enine, and that gets a side chain. And the rule says diene has a higher priority over enine. So, we should number it in the way shown as above. So, now let us try to understand what the name of this compound should be. In the previous slide, we have clarified how the numbering of the longest chain should be done. So, here what I have shown is the numbering of the carbon atom starting from the left corner to the right corner with 1, 2, 3, 4, 5, 6, 7 and 8. So, what we have here is at 5 position we have the ethyl group, at 3 and 7 position we have 2 methyl groups, as you can see. At 4 position we have a methylidine group. At 6 position we have this ethinyl substitution. So, what we should name this molecule as is written here at the bottom of the slide: 5-ethyl, 3,7-dimethyl, 4-methylidine, 6-ethinyl, octa-1,6-di. So, this is how we should try to understand and write the name of a hydrocarbon or a complicated molecule where you may have 2 or more double bonds and triple bonds present in the molecule. So, when you learn about cyclic alkanes, there are few very commonly encountered cyclic alkanes as are shown here: cyclopropane, cyclobutane, cyclopentane, cyclohexane, etc. These are very common cyclic compounds that we encounter in our organic chemistry courses. So, when we try to name those cyclic structures, so the cyclic structures always have higher priority over C double bond C or C triple bond C. So, this should be named as ethinyl is the substitution and cyclohexane is the parent that we have inside. Similarly, ethinyl is the substitution and cyclohexane is the parent that we have here. So, when we try to name the cyclic hydrocarbons, the side branches are numbered in alphabetical order. So, now we have 2 substitutions in this particular molecule, a methyl substitution and a propan 2-yl substitution. So, while numbering it, we should give methyl the first priority because M comes before P. So, we write it as methyl 1-methyl. At 2 position we have propan 2-yl because this is a 3-membered ring connected in the middle portion. So, we write it as 1-methyl 2 propan 2-yl cyclohexane. Now, we see here there are 2 possibilities of writing this name. We can have a cyclobutane and we name it as 1-methyl cyclobutane because the methyl group is attached to carbon 1 when I am numbering it like that 1, 2, 3 and 4. But if somebody numbers it in the opposite direction 1, 2, 3 and 4, the name should be 2-methyl cyclobutane because now the methyl group is here. What do you think the name should be? The correct name of this molecule should be this one, not that one, because the substitution is methyl gets the lowest number and cyclobutene also is at position number 1. As you all know that the other class of cyclic compounds are aromatic hydrocarbons and we have molecules like benzene, naphthalene, anthracene, etc. So, these molecules also we need to identify with appropriate names. Because of aromaticity, these molecules are more stable than some of the hydrocarbons. These are called adenes as well. So, when a group which is C6H5 is attached to any compound is called a phenyl group. Similarly, a naphthalene with 1 hydrogen less is called a naphthyl group and these are basically called the aryl groups. Then the next class of compounds that we encounter very frequently is the group of alcohols, and as you may know, the alcohols can be identified as primary, secondary and tertiary depending on the connectivity of OH with the carbon. So, if the OH is connected to a carbon which has 2 hydrogens, is called a primary alcohol. If the OH is connected to a carbon which is in turn only connected to 1 hydrogen, is called the secondary alcohol. And if you have the alcohol, the OH group connected to the carbon where there is no hydrogen atom, is called a tertiary alcohol or a 3-degree alcohol. So, it has a general formula of CnH2n plus 1 OH. So, 3 classes of alcohols that we can think of: primary, secondary and tertiary. So, when we try to now name these molecules, we first try to identify the long chain as usual and try to identify the position of OH group getting the lowest number. So, that is why we did not start numbering from the left side, rather we started numbering from the right hand side and made it as pentane to all. In the second case, when we have the OH group in the middle, it is imperative that one from either side it gets number 3. So, we do not need to worry about numbering from which side or whatever. So, we write it as pentane 3 all. There can be a molecule where you may have 2 OH groups. So, we should number the carbon chain in such a way that both the groups get the lowest priority. In this particular case, from either side these numbers will be 2 and 4. So, therefore, the name of this molecule will be pentane 2,4-diol. So, this is the family name of alcohol that gets associated is the phrase OL identifying the presence of alcohol. Now, you see that in this case E is retained in case of diol, where in case of enine that E was dropped. The other class of compounds containing OH group are the phenols. These are derived from aromatic hydrocarbons and contain one or more OH groups attached directly to the aryl groups. So, we write it as AROH, and common example of that molecule is phenol. So, here you have 2 molecules which are having these OH groups. One is phenol and the other one is 1,2-dihydroxybenzene, not 2-hydroxyphenol. Why is that? Because when you try to write the name, you cannot give one as a priority over the other if the functional groups are same. So, we write it as benzene 1,2-diol or 1,2-dihydroxybenzene and not 2-hydroxyphenol. The next class of compounds are ethers, where you can have 2 alkyl or aryl groups connected by 1 oxygen, and these are called the alkoxy groups, where you have a bond of R and oxygen. So, here in this case you can see one molecule, and we can write the name in 2 different ways. One way where we identify one group as ethoxy, because you have ethyl group connected to oxygen, and here it is a methyl group. So, we can write it as ethoxymethane or we can write it as methoxyethane. Now, by now you should be able to identify which is the correct name. The correct name is the second one, because here we have considered the long chain as the parent molecule and methoxy as a substitution. So, this becomes methoxyethane instead of ethoxymethane, because in that case methane is the parent which has less number of carbon atoms compared to ethane. The next class of compounds are the carbonyl compounds, where you have a C double bond O and the carbon is connected to two alkyl groups. So, those compounds have two different types, can be ketones and aldehydes. So, when you have one aldehyde, you have the family written as al, and in case of benzaldehyde it is written as aldehyde. So, methanal, ethanal, propanal, etc. are the common names of those aldehydes that we generally encounter. The aldehyde group, that is the CHO group, always occupies the terminal position of a molecule. So, no need to specify the position of this aldehyde group in a molecule. The carbon atom forming the aldehyde group is always given the priority number 1, and we do not need to mention that in the name of that particular molecule. So, we do not write as propan 1L, rather we write it as propanal. The ketones are the next type of molecules, next group of molecules, where the C double bonded O is associated with a carbon which has two carbon atoms connected to it. Everywhere, if you see that you have two carbon atoms connected to that carbonyl group. So, you can have the names following the IUPAC nomenclature. This compound, the top one, has 5 carbons, writing the name from the right hand side 1, 2, 3, 4 and 5. At 2 position you have ketone, so we write it as ONE, on, and 4-methyl is the substitution at position number 4. So, it is 4-methyl pentane 2-on. The next compound that we have here is 2-methyl pentane 3-on, because the carbon atom at number 3 contains the ketone carbonyl group or the ketone moiety. So, it is 2-methyl pentane 2-on. So, I leave the other 2 ketones for you to identify the name of those compounds. The next type of organic molecules that one can encounter or one can think of are the carboxylic acid, where you have a C double bond OH, this kind of functional group called the carboxylic acid group, and these carboxylic acid groups are again at the terminal position. So, we do not need to identify the position of it until and unless it is absolutely necessary. No need to mention the specific position of it. So, in case of carboxylic acids containing aromatic rings, so those are the benzoic acids. When you have a substitution on benzoic acid, we can write it as 2-hydroxybenzoic acid. You see here the priority of carboxylic acid is given over the priority of OH group, and then you can have 3-methyl benzoic acid. So, the carboxylic acid gets higher priority over the methyl group. Now, we have one example here. We have a 6-carbon chain molecule and we have carboxylic acid at either end. Depending on how you identify, whether you identify this as 1 and that end as 6 or this end as 1 and that end as 6, both are hexane dioic acid, because there are dicarboxylic acid, we write it as dioic acid, and we do not identify them as these positions which I have already mentioned. So, it will be 1,6-hexane dioic acid, it will be hexane dioic acid, not 1,6-hexane dioic acid. There are different acid derivatives. So, when you have an acid and you replace the OH group by a chloride, you get acyl chloride or acid chloride. When you have two acid groups joined together by dehydration process and form a new type of molecule which is shown here, this has a RCOO C double bond O R kind of moiety, that is called the acid anhydride, and it is possible that there may be R and R groups which are different and it forms a mixed anhydride. The next type of acid derivative is the reaction product of an acid with the alcohol, where it forms an ester that you can see on the right. This linkage is called the ester group, which you may know that has a very nice fruity smell to identify an ester. The other derivatives of acid can be amides. So, when the acid is treated with an amine, it forms a CONH group, as you can see on the right. So, this is called the 1-degree amide, and the other one is called the second 2-degree amide. So, when you have ammonia, it forms 1-degree amide. When you have an amine RNH2 group, then it is 1-degree amine forms a 2-degree amide. Let us now try to understand the naming of acid derivatives, where we are trying to learn how to name the acid anhydrides. So, when you have a benzoic acid or carboxylic acid, we write it as oic acid. So, when that acid is converted to an anhydride, we write it as OIC, oic anhydride. So, you see there is a space between oic and anhydride, and as I indicated in the previous slide, that there may be a mixture of acids which can give you a different anhydride. So, when you have mixed anhydride, the parent acids are named in alphabetical order. So, the parent acid here is ethanoic acid. In this case, the parent acid is propanoic acid. So, the name that we identify for this type of molecule is ethanoic propanoic anhydride. So, with this I would like to end this lecture, and we will continue the discussion on nomenclature from here in the next lecture. Thank you.